The focus of this lesson is identifying special segments and lines intersecting circles. Let's start with a very simple definition, that of a circle. A circle is defined as the set of all points in a plane that are equidistant or the same distance from a given point called the center of the circle. A circle with center P is called circle P and can be written as circle P, or with a little circle and a dot inside P. There are a few other definitions that we need to introduce today in order to make sense of this chapter. The first of which is the radius. A radius is defined as a segment whose endpoints are the center and any point on the circle. Then we have what is called a chord. And a chord is defined as a segment whose endpoints are both on the circle. Note, a radius is not a chord because it has one endpoint on the circle and one endpoint inside the circle, whereas a chord has both endpoints touching the circle. A diameter is a special type of chord that contains the center of the circle. So we see that it's a chord because it touches on both ends and it goes directly through the center. A secant is a line that intersects a circle in 2 points. So we see that here marked in green. And a tangent is a line in a plane of a circle that intersects the circle at exactly 1 point. That point is referred to as a point of tangency. The tangent ray, AB, and the tangent segment, AB, are also called tangents. So to be tangent is to touch in one place. To be secant is to touch twice. Example 1. Tell whether the line, ray, or segment is best described as a radius, a chord, a diameter, a secant, or a tangent of circle C. Let's start with A. So part A is referring to segment AC. Looking at the image, we can see AC. A touches the edge of the circle. C is in the center of the circle. This, thus, is the radius. Now let's look at part B, segment AB. A is on this edge of the circle, B is on the other side of the circle, and AB goes through the center of the circle. AB must be defined as the diameter. Part C, ray DE. Ray DE touches the circle at point B and only touches the circle once. Thus, ray DE must be a tangent of the circle. Last but not least, line AE. Line AE goes through the circle, and it looks like touches the circle at points A and G, thus must be defined as a secant to the circle. Go ahead and give it a try. Tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or a tangent of the circle. Pause the video and give it a try. Compare your answers with a neighbor. Let's introduce a couple more definitions. In a plane, 2 circles can intersect in 2 points, 1 point, or no points. Coplanar circles that intersect in 1 point are called tangent circles. So for example, we see those here in red. We see 2 circles intersecting in 1 point in both of these images. Thus, these circles are tangent to one another. Coplanar circles that have a common center are called concentric circles, as we see here on the right. A line or segment that is tangent to 2 coplanar circles is called a common tangent. A common internal tangent intersects the segments that join the centers of the two circles. A common external tangent does not intersect the segment that joins the centers of the two circles. So right here on the left, we can see we have a common external tangent, whereas right here on the right, we have a common internal tangent. Because if we were to draw a line through the centers of these circles, it would be going through this tangent. Example 2. Tell how many common tangents the circles have and draw them. Use blue to indicate common external tangents and red to indicate common internal tangents. Let's start with part A. We're going to say that we have a common tangent if the line touches both circles just one time. We would like to use blue to indicate common external tangents. Okay, I'm going to draw this as straight as I can. There we go. There's one external tangent. It touches once here and once here. Similarly, we can draw another. We're going to pretend that touches once here and once here. So we have here two common external tangents. And then there are no common, well, actually, there are common internal tangents. Let's go ahead and draw them. So we're going to draw a line that goes through the center that touches here once and then there once. And we're going to see that as tangent here and here. And similarly, we can draw one the other direction. Now note these lines should be straight. It's just difficult to draw these straight by hand, but they touch once and once. We have a total of 2 internal and 2 external for 4 common tangents. All right, let's look at part B. We'll start with our internal tangents. So note here, there will only be one internal tangent because the circles touch. But just like before, there will be 2 external tangents. Here and here. Note, touching once on each. So 3 common tangents. Now let's look at part C. Part C has 1, 2 external tangents. And if we look closely, we notice because the circles overlap, there are no internal tangents. So 2 common tangents. And that's it. Go ahead, tell me how many common tangents the circles have, and draw them. State whether the tangents are external tangents or internal tangents. Pause the video and give it a try. Check in with a neighbor to see if you agree.